Hello guys, thank you so much for watching my video today. We are going to discuss the convergence of a series. Okay, when is a series said to be convergence? Okay, and divergent also there, and there are some other also there. Okay, now since we are going to talk about convergence of series, first of all we have to know what do you mean by convergence, right? So convergence series mean, okay, so convergence series, an infinite series. Okay, convergence series is an infinite series like this: u1 plus u2 plus u3 plus and so on plus un plus and so on up to infinite, right? Then is what I call infinite series. So an infinite series of this one is said to be convergence if Sn, the here Sn we denote Sn, then is the sum of its first and terms. Okay, the sum of its first and term tends to a finite limit s and tends to infinity. So symbolically we write s equal to limit n tends to infinity Sn. This Sn is nothing but the sum of its first and terms. Okay, and if this limit tends to a finite, then we say that this series is a convergence series. Example, let's see here. Let's say Sn is 1 over 1 plus 1 over 3 plus 1 over 9 plus and so on plus 1 over 3 to the n. Hence, or let's test for this convergence. Okay, so for L, let's say this series, infinite series, let me represent by L. Okay, L equal to limit n tends to infinity Sn. Sn is this one. Yes, if you see this one, okay, it is 3 by 2. So the value is 3 by 2. Yes, and n approaches infinity, so therefore this all or convergence or infinite series L tends to a finite limit, right? This is 3 by 2, so therefore we say that this series is a convergence series. How does it come 3 by 2? We are going to discuss, okay, in the next video. Okay, do not worry about that. Now, since we have talked about convergence series, let's discuss divergence series also. So divergence series, convergence series means an infinite series tends to a finite limit s and tends to infinity, right? This is the symbolized form. So divergence series will be opposite of that, right? If Sn tends to plus or minus infinity, Sn tends to infinity, so the series is said to be divergent. Here, in this series, if you let n approaches infinity, then this series tends to a finite limit, right? So this is what we call convergence. So similarly, if this series does not tends to a finite limit, okay, then we call it a convergence series. Okay, divergence series. Example like sum of natural number 1 plus 2 plus 3 plus and so on. This is actually a divergence series, because if you let limit n approaches infinity, then you'll get infinity, right? Because sum of natural number up to n terms is given by n plus 1 by 2, right? So if you let n approaches infinity, so this is infinity plus 1 by 2, so this is infinity. So because of that, it approaches infinity, so this series, then is the sum of natural number, is a divergence series. Now, since we talk about convergence, divergence, now let's talk about oscillating series. Okay, what do you mean by oscillating? Oscillate means like something like this. It oscillates, pendulum, right? If you look at the pendulum, it oscillates like this, right? Then is what we call oscillating series. If Sn does not tends to finite limit or plus or minus infinity, then the series is said to be oscillatory. They mean oscillating series. If it is not convergent or divergent, then we call it oscillating series. Okay, let me give you one example. Here. Okay, example. Let Sn is equal to 1 plus negative 1 to the n. So if limit n approaches infinity, then this series, okay, is it will oscillate between 0 and 2. 0, 2, 0, 2, 0, 2. Example, like if you put the value here, so 1 minus 1 plus 1 plus 1 plus 1 minus 1 plus 1 plus 1 plus and so on, like this, right? So this is 0, this is 2, this is 0, this is 2. So therefore these types of series, it oscillate between 0 and 2, right? Therefore this is what we call oscillating series. Now since we talk about infinite series, now let's see the definition. Okay, infinite series, an expression of the form a1 plus a2 plus and so on up to an plus so on, where each an is a real number. Here a1, a2 or an and so on is a real number, is called an infinite series of real number and is denoted by, meaning infinite series means it goes up to infinite, right? Infinite terms. So we denote these types of series, infinite series, by this Greek symbol sigma, right? Sigma from n equal to 1 to infinity an, or just simply sigma an, right? Where an is called the n terms of the series. Okay, this an is what we call the n terms. If you check out the arithmetic progression GP, HP, right, you will see that n terms there. Okay, so this sigma is to denote summation. Okay, so example like summation of n equal to 1 to infinity 1 over n squared. This is if you take out this symbol, then you get 1 plus 1 by 2 squared plus 1 by 3 squared plus and so on. So this goes up to infinite. Okay, these types of series is what we call infinite series, or something like this. Okay, up to infinite. Okay, now here I give some note. The series which are divergent or oscillatory are often said to be non-convergent. Okay, like a series like a divergent or oscillatory, and that what we call non-convergent series. Okay.